Ever tried to fetch data from an API, only to be met with that infuriating blocked by CORS policy error in your browser console? Yeah, we've all been there, staring at a perfectly good request that just dies. This isn't just an annoying error. It's a fundamental web security feature that can feel like a brick wall. That little error message can single-handedly derail your entire development day, turning a simple API call into hours of frustrating debugging. It's a rite of passage for every web developer, but it doesn't have to be a recurring nightmare. By the end of this video, you'll not only understand why CORS blocks requests, but you'll also have the knowledge to confidently diagnose and fix those pesky errors, turning frustration into aha moments. The root cause, same origin policy, SOP. Okay, so before we even touch CORS, we need to talk about its older, stricter sibling, the same origin policy, or SOP. This isn't some arbitrary browser rule. It's a fundamental security principle baked into every modern web browser. It's designed to prevent malicious websites from reading sensitive data from other sites you're logged into. So, what exactly defines an origin? It's a combination of three things: the protocol, the host, and the port. If even one of those is different between your frontend application and the API you're trying to hit, BEM, different origin. For example, http://example.com. 8080 is different from https://example.com because of the protocol, and from http://api.example.com because of the host. Real talk, SOP is a good thing. Without it, any random website could potentially make requests to your banking site, read your emails, or steal your session cookies. It's the bouncer at the club, making sure only authorized guests get in. But what if you do want two different origins to talk? That's where CORS swoops in. CORS, the exception handler. So if SOP is the bouncer, then cross-origin resource sharing, or CORS, is the special VIP pass. It's a mechanism that browsers use to allow controlled access to resources from different origins. It's not something you configure on your front end, at least not directly. CORS is primarily about the server telling the browser, hey, it's cool, you can let http://localhost 3000 access my stuff. Honestly, I think a common misconception is that CORS is a problem on the client side. It's not. Your client-side code is trying to make the request, and the browser is blocking it because the server hasn't given explicit permission. So, if you're hitting a CORS error, your fix almost always lies with the backend API you're trying to consume, or a proxy in front of it. So, when your browser sees a cross-origin request, it sends it off. The server then needs to respond with specific HTTP headers that tell the browser, yep, this origin is allowed, or no, sorry, denied. The browser then checks these headers, and if everything aligns, it finally allows your client-side JavaScript to access the response. If not, you get that glorious console error. The mysterious preflight request. Now, here's where it gets a little wild. Sometimes, your browser doesn't just make the request directly. For certain complex requests, it'll send a preflight request first. This is an options HTTP request that goes to the server before your actual GET or POST request. It's essentially the browser asking the server, hey, I'm about to send a real request from http://myapp.com. Are you cool with that? And what methods and headers are allowed? What makes a request complex? Generally, it's anything that isn't a simple GET, head, or POST with specific content type headers like application/xww formal encoded, multipart/form data, or text/plain. So, if you're sending application/JSON with a POST or PUT request, or using custom headers, you're almost certainly triggering a preflight. This is why you sometimes see two network requests for one API call in your dev tools. The key takeaway here is that your server must be configured to handle these options requests and respond with the appropriate CORS headers before the actual request even arrives. If the preflight fails, if the server says nope to the requested method or headers, then the actual request is never sent, and you get a CORS error. It's a silent killer of requests if your backend isn't ready. Still with me? We've peeled back the layers on why CORS exists and how preflight requests work, but understanding the why is only half the battle. Next up, we're diving into the exact headers you need and, crucially, how to actually fix those stubborn CORS errors. This is where you turn theory into practice, so stick around. Key CORS response headers explained. Alright, let's get into the actual HTTP headers your server needs to send back. The absolute star of the show, the one you'll see most often, is access control origin. This header tells the browser which origins are permitted to access the resource. It could be a specific URL, like http://localhost 3000, or for development, and sometimes public APIs, a wildcard asterisk meaning any origin. Then there are access control methods and access control headers. These tell the browser which HTTP methods, like GET, POST, PUT, DELETE, and which custom headers, say, authorization or X requested with, are allowed when making the actual cross-origin request. These are super important for those preflight requests we just talked about. If your server doesn't explicitly allow a method or header that the client is trying to use, the preflight will fail. Finally, there's access control allow credentials. This one is crucial if your frontend needs to send cookies, HTTP authentication credentials, or client-side SSL certificates with your cross-origin requests. If you set this to true, then access control allow origin cannot be asterisk. You need to specify the exact origin. This is a security measure, preventing arbitrary sites from reading your authenticated session data. Common CORS errors and how to debug them. Okay, so you've seen the errors, but what do they mean? The most common one is no access control origin header is present. This usually means your server simply isn't sending any CORS headers, or the access control origin header it is sending doesn't match your frontend's origin. Double check your backend code for where you're setting these headers. Another classic, Nginx is not allowed by access control origin. This means your server is sending the access control origin header, but the value it's sending doesn't include your frontend's origin. Maybe you allowed http://example.com, but your frontend is running on http://localhost 8080. Or, hot take, you probably forgot to include a trailing slash, or added one where it shouldn't be. URL matching has to be exact. Finally, method y is not allowed by access control methods, or request header field z is not allowed by access control headers. These are preflight errors. Your server either didn't respond to the options request at all, or its access control methods or access control headers response didn't include the method or header your client is trying to use. Go back and ensure your options handler is comprehensive. CORS in dev versus production and proxy solutions. Okay, so you fix CORS locally, but then you deploy to production and suddenly it's broken again. Wild, right? This often happens because your development environment like localhost 3000 is treated differently than your production domain, https://myapp.com. In production, you need to make sure your backend explicitly allows your production frontend URL. For local development, a common and super handy trick is using proxy. If you're using Create React App or Vue CLI, you can often add a proxy field to your package.json. This tells your dev server to forward requests from your frontend to a different origin, making it look like a same origin request to the browser. It's a lifesaver for avoiding CORS locally without changing your backend. In production, however, you typically don't use a package.json proxy. Instead, you configure a reverse proxy like Nginx or use an API gateway that sits in front of your backend services. These proxies can intercept requests, add the necessary CORS headers, and then forward them to your actual backend. This keeps your backend clean and handles CORS at the network edge, which is generally a more robust and scalable solution. Let's recap. The same origin policy, SOP, is a core browser security feature, blocking cross-origin requests by default. CORS is the server-side mechanism that explicitly grants permission for cross-origin requests via HTTP headers. Preflight options requests are sent by the browser for complex requests to check server permissions first. Key CORS headers like access control origin, access control methods, and access control headers control access. Debugging CORS means checking server-sent headers and ensuring exact origin matches, especially for credentials. The key takeaways: always configure CORS on your backend or a proxy, not your frontend. When debugging, inspect network requests for options responses and actual API responses to see which CORS headers are present. For local dev, use a frontend proxy, like in package.json. For production, use Nginx or an API gateway. Be precise with origins. http://localhost 3000 is different from http://localhost 3000/ or https://localhost 3000. If this helped you finally understand why those blocked by CORS errors happen, and more importantly, how to fix them, consider supporting the channel. Every bit helps us keep these deep dives free for everyone. Drop a comment with your worst CORS debugging story.